Ki versus Keq. So Ki, sometimes called Q, is the instantaneous K value based on your Keq expression. Well, what does that mean? It's basically saying, all right, if I have these concentration of these reactants and products in my container, given what you know is your Keq value of your reaction under these conditions, is your system at equilibrium or not? So I do that by plugging in the given values into my Keq expression, and then I evaluate, is my Ki equal to my Keq? If it is, it's at equilibrium. If it's less than my Keq value, then my system's not at equilibrium. If my Ki is less than my Keq, then I need to increase my product concentration and decrease my reactant concentration. In other words, I'm at the beginning of my reaction and it hasn't quite reached equilibrium yet. So I need to have my reaction continue so that I create more products. I need to favor my reactants to products reaction. And we call this a system needing to shift right. So shifting right just means I need to take my reactants and create more products. It's another way of saying I need to drive the reaction forward more than backwards, and that forward reaction needs to predominate to reach equilibrium. So shifting right means I don't have as much product as I need, so I need to create more products and I need to lose my reactants. So remember that the products come from the reactants. If my Ki value is greater than my Keq value, again, my system's not at equilibrium. And in this case, my product concentration is too high, and my reactant concentration needs to increase. So it's kind of like I overshot, and so now I have to shift things back over. So I need to shift left, which simply means I have to take my products and I dismantle them, decompose them, whatever the reverse reaction is, to create more of the reactants. So I want the leftward or the reverse reaction to predominate. So the shift right, shift left comes from the fact that we always write reactants on the left side and products on the right side. And so depending on whether I'm trying to make more products, shift right, or lose my products to create more reactants, shift left, that's where the terminology comes from. So here's our first example, decomposition of Nh3 gas. So my Keq value is given as 2 times 10 to the negative third. The concentrations I'm looking at in my container right now are 2 times 10 to the negative third for Nh3, 4 times 10 to the negative 1 for H2, and 6 times 10 to the negative 2 for N2. One thing that's important to realize is that these don't have to be in stoichiometric proportions, right? I'm not seeing which way they're going to be, which way they're going to react. I'm just asking, if I just happen to just dump these gases into this container, will it be at equilibrium or will it have a reaction predominating one way or the other? So these values, again, don't have to have anything to do with the coefficients here. My Keq expression does, though, right? So the first thing I have to do is write my Keq expression before I even do anything else. So H2 cubed times N2 over NH3 squared, and that's equal to my given Keq of 2 times 10 to the negative third. So my first question is my system at equilibrium? So I plug these values in, and I say, all right, what is this? Are these values, when I cube this, multiply it by this, and divide it by this squared, how does that relate to my 2 times 10 to the negative third? So I plug in the values that are given. And the easiest way to do this is to do this by inspection first. Basically, I just tackle the exponents. So I just say, rather than 4, 6, and 2, I just write 10 to the negative first cubed times 10 to the negative second over 10 to the negative third squared. And that becomes 10 to the first. 10 to the first is way higher than 10 to the negative third. I don't have to do this 4 times or 6 times or whatever in order to see that. In fact, this is only going to make it closer and closer, actually higher and higher, times 10 to the first, right? So on inspection, I can already say that my Ki value is much, much greater than my Keq value. I don't need to be more precise because the difference is so huge. So if my Ki value is so huge, that means I have too many products, and so my system has to shift left in order to actually establish equilibrium. So if I dump these concentrations, these gases, into this container, under these conditions in which the Keq value is 2 times 10 to the negative third, it will not be at equilibrium, and it will work to achieve equilibrium by shifting left, basically causing the composition reaction to occur over the decomposition reaction. The Ki can also be used to tell if your solution is saturated or not, right? So if my Ki is equal to my Keq, my solution's saturated. I can't get any more thing to dissolve. If it's less than my Keq, that means it's unsaturated. I can dissolve more of my substance. And if it's greater than that, then there's too many dissolved particles and a precipitate will form. And we see this not just with an ion concentration gets lower, we see this every time it rains, right? So every time it rains, basically what's happened is that my temperature has decreased, or something has happened, to the point where my Ki, the amount of water vapor in the atmosphere, is greater than the amount of water vapor that should be able to be there. And so the excess water vapor comes out in the form of rain or snow or fog or whatever, depending on the temperature, and I reestablish the equilibrium for that situation. Back to ions, though. All right, so if I say my Keq value for barium chloride is 4 times 10 to the negative fifth, if the ion concentrations of barium are 3 times 10 to the negative second and chloride is 4 times 10 to the negative third, what is true about my solution? Am I at equilibrium? Have I overreached equilibrium? What's going on? So I write my Keq expression, which is my barium ion concentration times my chloride ion concentration squared, again, going with my coefficients here. And I don't include barium chloride because it's a solid. And I make that equal to 4 times 10 to the negative fifth, my given Keq value. I plug in my values and say, all right, again, on inspection. So just my 10 to the negative thing. So 10 to the negative second times 10 to the negative third squared is equal to 10 to the negative eighth. That's so much smaller than 10 to the negative fifth. It doesn't matter what I do to these things, right? 4 squared is 16 times 3. That's 48. 48 times 10 to the negative eighth is not bringing it any closer to 10 to the negative fifth. So much smaller, don't even have to worry about those numbers. And so I can say that my Ki value is definitely smaller than my Keq value. My solution is unsaturated. I'm not at equilibrium. I can dissolve more barium chloride in this solution because I haven't reached the limit of solubility. In that case, I can't shift right or shift left because I don't have enough in there. All I can say in this situation is that I have an unsaturated solution. So to recap, you can talk about shifting right, shifting left if I have enough products and reactants in order to shift right or shift left. But if I don't, then all I can do is talk about where I am in the process. Do I have an unsaturated solution or not? Have I reached equilibrium or not?